Dear students, today we are going to discuss about property number 5, and this property number 5 really most important property among other properties of determinants. But some students may get confused to use this property. First, I'll try to expand the complete examples, and I'll try to make you to understand the meaning of the property. Then we'll go for the derivation. So this property, different textbooks, different authors, different lecturers may explain you in different ways, but finally the meaning of this property remains same only. So what is that? First, let me explain this part. Suppose first through example, I'll try to just clear this concept. Once examples are cleared, then we'll go for the derivation. Suppose we consider just determinant here, 3 minus 1, 2, 1, 1, 3, 2, 3, 4. Suppose this determinant, suppose this is the given determinant. So if you expand by using first row, second row, or third row, or first column, second column, or third. So as we know that if the determinant is being expanded by using any row or column, the value remains same only. Suppose see that already I have solved this one. Think that, so we got this answer is minus 15. The value of this determinant is minus 15. So 3 minus 1, 2, 1, 1, 3, and 2, 3, 4. Now, so what the first definition is, here this is the same determinant. Now, you take any row or any column, But suppose in this example, I have taken it as second row. I have taken second row. We multiply each and every element in second row by some constant number. Say example, I'm going to multiply by 5. So 3 minus 1 and 2. So this is each and every element is I'm multiplying by 5. That is 5 times of 1, 5 times of 1, and 5 times of 3. 2, 3, 4. So like this, that is please try to understand. If you multiply every element of any row by some constant number, then what is that? The answer, that is, this is minus 15. The total, its determinant has to be multiplied by that constant number. That is, the final answer will be minus 75. So this is your textbook theorem says that. So textbook, according to your textbook, what is this? In any determinant, every element of any row or any column is multiplied by the constant k. Then the value of the determinant has to be multiplied by k. Multiplied by k it is. So again, I'll give you one more example now. Suppose, look at this. Set of example only. Suppose 1, 1, 2, 3, 4, 5, and 5, 1, 5 minus 1, 3. Suppose this is the determinant I've given. So just think that the value of this determinant is say 2. How much? This is 2. Just simple. Just don't think that it's correct. If you expand it, it may be wrong also. Just think that it is 2. Now, here, this time I have taken row. Here, this time I'm going to take column 3. Column 3, every element of column 3 has to be multiplied by some constant. Suppose I have decided that is equal to 2 times of column 3. Every element, that is what? 1, 3, 5, 1, 4, minus 1, and 2 times I'm multiplying now 2 into 2, 2 times of 5, and 2 times of 3. So what is that constant number? 2. Then after multiplication, what is the value of this determinant now? This determinant is this 2 old value will be there. That value has to be multiplied by that constant number. That constant number, that is 2. That definitely the value of this new determinant will be 4. So what is this thing is? Now here the final example I am going to take now. Suppose here A, B, C, D, E, F, G, H, J. This is the determinant. So I got, this is the determinant is, say it is M. Now here first row I multiplied by K, that is constant K. Every element of first row is be multiplied by K. That means Ka, Kb, Kc, D, E, F, G, H, J. Now what is the value of this determinant is? Very simple. The first value has to be multiplied by the constant K. From which constant you have multiplied every element of a row, with that you have to multiply. Therefore the answer will become Km. This is the one way. So once again I'll tell you, in any determinant, this is the determinant. If every element of any row, not only row or column, every element of any row or column is multiplied by constant K, then the value of the determinant has to be multiplied by K. So this is the one way to express property number 4. If you are not clear, once again I'll just finally give this idea how to express property number 4. Property number 4 it is. So the property number 4 is, suppose see, here we have taken this. Once again, look here. First beginning I have taken, suppose the determinant is A1, B1, C1, A2, B2, C2, and A3, B3, C3. This is the determinant. Suppose think that this determinant, the value of this determinant is suppose N. Now what you have to take? Now in this, every element of any row or column, has to be multiplied by some constant K. So suppose, and R3, I am going to multiply constant K times of R3. Every element, suppose A1, B1, C1, A2, B2, C2, KA3, KB3, and KC3, then the value of this determinant will be what? The value of the previous determinant, the first determinant, has to be multiplied by that constant K. So how he may ask this, this is the property in the examination. In any determinant, that means it may be 2 by 2, 3 by 3, 4 by 4, 5 by 5, like n by n. Any determinant, every element, this is the determinant, every element of any row or column is multiplied by constant K, then the value of the determinant has to be multiplied by the constant K. This is one thing. Now the second way of expressing this, the same, it's a different meaning is what? Here A1, B1, C1, A2, B2, C2. So here KA3, KB3, and KC3. This is the determinant. See, in which in which every element of R3, every element of third row is multiplied by constant k. Or what is the other meaning is, the other meaning of this property number 4 is, if there is a common factor in any row or any column, the common factor can be taken outside the determinant here. Look at it. A1, B1, C1, first row, no common factor. You can write here A1, B1, C1. No common factor. Second row, there is no common factor. A2, B2, C2. And third row, K is common factor. You can take outside K. And A3, B3, C3. So this, you will be perfect. You will be learning properly. When you solve different example, definitely will come to know. That means the same property number 4, some textbooks, they may twist the question like this. In any determinant, if there is a common factor in any row or column, then the whole determinant will be multiplied by k. Then the whole determinant is multiplied by k. Or in any determinant, if there is a common factor k in any row or column, the common factor can be taken outside the determinant. The common factor can be taken outside the determinant. So this is one meaning it is. And second, the same property, third way, that is, once again, in any determinant, any two rows, the elements of two rows, in any determinant, the elements of any two rows or two columns are proportional, then the value of the determinant is 0. So that is also one of the most important theorem now. So this is the two ways you can understand. So my dear students, what here? The property number 5, what it states, in any determinant, if every element of any row or column is multiplied by the constant k, then its determinant, the value of the determinant is multiplied by k, then its value gets multiplied by k. So today we are going to prove this. Or in any row or any column, if there is a common factor, the common factor can be taken outside the determinant. So this is one thing. Now look at this. So the property I'll write and I'll explain this part. Yes. So property number 5. This is the property number 5. If each element of a row, if each element of a row, not only row, or a column, if each element of a row or a column of a determinant of a determinant is multiplied by a multiplied by a constant, k, then its value gets multiplied by k. Multiplied by k. So this is the property number 5. See that. First we'll take a proof directly, I'll go for it. better it is, don't without wasting time, proof. This is, of course, when the college reopens, I'll give with example. Overall, what happened, this is a property number 5, but of course in the textbook it is property number 4. I'm not following the serial numbers from your textbook. Look at carefully this. So here what happened, I'm going to just consider, first you take it is A1, B1, C1, A2, B2, C2, and A3, B3, and C3. This is the determinant first you have taken. So suppose this is, you think that let its name is delta. Let take delta is the determinant or first determinant. Or A1, B1, C1, A2, B2, C2, A3, B3, C3.